Number 4, the tip of a one-link robot is located at theta equals pi over 6 radians. Let's call that pi over 6. That's at time t equals 0. It takes 2 seconds, this is important here, for the robot arm to move from theta equals pi over 6 to theta equals pi over 6 plus 2 pi radians. Why? What does that mean? Well, if that's pi over 6, if I add 2 pi to that, it's going to be in the same exact position, isn't it? Those are coterminal angles. This is the same as pi over 6 plus 2 pi, pi over 6 plus 4 pi, and so on. Any even number in front of the pi. You could also say pi over 6 minus 2 pi, and the same thing is true in the negative direction. These are coterminal angles. And if it takes me 2 seconds to go from that point all the way back to the same exact point, that's the same as a cycle. And one cycle is the same as what we call a period. I also know that my phase angle, since it's placed pi over 6 right here, it would normally be at 0, but it's displaced. So that becomes my phi equals pi over 6. Let's continue to read. If L equals 10 inches, oh, this is L. This equals 10 inches. That means that this is not a unit circle. This is a circle of radius 10, and I can say that my amplitude is equal to 10. And that's where I get it from. That's really all the information I have. Let's look and see. So we found the amplitude. We did not find the frequency. We found the period. We found the phase angle. We did not find the time shift. That means we have to go back and find the frequency. The frequency is equal to 1 over the period, which is equal to 1/2. Now we found our frequency. Done. Time shift. What the time shift does, remember, we take our original equation, which would be, let's write our equations. We have x of t is going to equal a, which is 10, cosine of omega we did not find omega. We have to find omega. And then we also have to find our time shift. Remember what happens. We have omega times t plus or minus, doesn't matter. This one's going to be positive. And here we have our phi, and we're going to have to divide it by omega because we are factoring the omega out of the function. If I want to find omega, remember we have a formula. Our period is equal to 2 pi over omega. We know our period is 2. We solve for omega, and we get omega equals 2 pi over 2, which equals pi. All right, now I know omega. We can plug that in. X of t is equal to 10 times the cosine of pi times t plus phi. Phi we said is pi over 6. We're factoring out a pi. Pi over 6 divided by pi, which equals 10 cosine of pi times t plus 1/6. And y of t, the y value, is going to be 10 times the sine of pi times t plus 1/6. And now I have my x of t and my y of t, which is what I have to plot. My time shift equals 1/6 left. And I got it from all of these, or I used my shifted form to get 1/6. On the next page, I'm going to draw those graphs. All right. And my cosine graph starts at 1 when t equals 0, x of t equals 1. When t equals pi over 2, x of t equals 0. Pi, -1, 3 pi over 2, 0, 2 pi, 1. And similar in this direction. Right now, the green is y equals cosine of t. That's it. What we have to do is we have to fix our horizontal axis. How do I do that? I take each one of these points, for example, pi over 2 divided by pi. Remember that to find my period, I take 2 pi, which is the last value here, and I divide it by omega. Our omega is pi. So I'm going to divide that by pi. If I divide that by pi, I have to divide every other point by pi so it stays proportional. This is equal to 1/2. That means that this first point here is 1/2. Where we have pi, that's going to be 1. Pi divided by pi is 1. Basically, what's going to happen is all the pi's are going to get erased, and we're going to end up with 1/2, 1. 3 halves, which is 1.5, 2. And the same in the negative direction. You can divide each point if you like. We have 1/2, negative, -1. Okay, that takes care of my horizontal axis. Now, what I have to do is I have to multiply by my amplitude. That means, because my amplitude's in the y direction, these become +10 and -10. Now I've done everything except for account for the fact that this graph is shifting left by 1/6. Let's do our best. What I'm going to do is I'm just going to hit copy, I'm copying this graph. This is gonna be harder to do, obviously, without a computer. Paste. I'm gonna line them up with each other exactly, as close to exactly as I can get. And then I'm gonna shift it over. Let's call that 1/6. That is our shifted graph. The blue is our shifted graph. It's being shifted 1/6 to the left. I'm certain it's not precise since I didn't measure it out, but I think it gives the impression that you understand, hopefully. Now, we're going to do the same thing for sine. And I think what I'm going to do is just really copy this. Because really everything is going to stay the same except for one thing. So if you can guess. The sine graph looks a little bit different than the cosine graph, but that's all. What I want to do is I want to grab my blue graph and my green graph. All right, well, I did a little bit behind the scenes here, but I just took that graph, copied it, and put it on this coordinate system. And notice this one is going through 0, 0. The green line is going through 0, 0 because that's the original sine graph. And the blue is shifted left by 1/6. And those are my X and Y graphs.